Alright, so we have perfect numbers, they equal the sum of their factors, but we don't include the number itself. So for example, the number 6, it has factors, so 1 and 6, but we don't include the 6. 2 and 3, and that's all. And they add 3, 4, 5, 6, up to 6. 28, let's check that one. So we have 1 and 28, but we don't include the 28. 2 and 14, no 3s, 4 and 7. So if I add all those together, you'll see we get 28. So they are called perfect numbers. So we're going to look at this number, to the power of n minus 1 times to the n minus 1, and show that it is a perfect number if this is a prime. To the n minus 1 is prime. Alright, so it's only factors are itself and 1. Okay, so that one, only factors are itself and 1, so that's all nice. So that's the inside of 1 there. So we'll just look at this part first, to the n minus 1. If we look at the factors, let's consider the factors of 2 to the n minus 1. Okay, so we think about it, we could get 2 to the any power from 0 all the way to n minus 1 as factors. So we could get the 1 to the 0, to the 1, 2 squared. We could go all the way up to, now this one we're including it because it's only part, it's not the whole number, it's just part of that whole number. So these could all be factors. So let's add them together. So really this is just a geometric sum here. First term's 1, ratio is 2, so the sum of there's n terms here. So you can see we would get r to the n minus 1 on r minus 1, which is just 1. So there's the sum of all the factors for just the part to the n minus 1. So if I rub that out and just say, just for that part. But remember, each of those factors could then be multiplied by this factor, which is a prime, so we're not worrying about the factors of it, just by that factor itself. Would give us a whole list of more factors. So let's look at that one. So now consider all the factors of here to the n minus 1, all those factors, but now we're multiplying these factors by to the n minus 1. Alright, so let's look at those. So we are going to get 2, let's just times them by 2 to the n minus 1. So we could have this factor times 2 to the n minus 1, we have this factor, we could have this factor, all the way up to this. Now this factor times 2 to the n minus 1. Now the problem with that one is then we're including the whole number, which we're not allowed to, so I'm going to have to subtract that one in a second, but let's add it all, and then actually I could put it here, and then actually subtract that one. Just easier to add it in, but then we can subtract that one. Alright, so again you can see, so the total sum of all these factors would be, we know that when we sum those up we get that, 2 to the n minus 1 from here. But we need to subtract that last one, which was 2 to the n minus 1, to the n minus 1. So if I just factorize by 2 to the n minus 1, we're getting 2 to the n minus 1 minus 2 to the n, I could put minus 1, so I could put divided by 2 there. So you can see here we're getting 2 to the n minus 1, and here we've got one of these, take away a half of them, so there's going to be a half of them, which is the same as 2 to the n on 2, which is 2 to the n minus 1, minus 1. Alright, so that's the number of factors once when they're times by that. So when they include 2 to the n minus 1 bracket, I get this many. When they don't include that, I get this many. So in total, let's add those two together somewhere up here, perhaps. I'll do it in a different color. So my total number of factors then, so if I'm adding all the factors together, I'm going to be adding 2 to the n minus 1 plus, so that's that one, plus this many, So this many was 2 to the n minus 1, 2 to the n minus 1, minus 1. So I hope I wrote that down correctly. All right, so if that's the case, then I'll just give us a bit of space here. Have a look. So they both have 2 to the minus 1, so I'll factorize by that. So there's 1 plus, and then there's 2 to the n minus 1 minus 1. So you can see there the ones will cancel. So I've got 2 to the n minus 1 lots of 2 to the n minus 1 factors, and that gives us the actual number. So this number must be a perfect number. So the sum of all those factors equaled the number itself. We just excluded the actual number itself in the factors. All right, I hope that made sense.